So I actually changed like a little bit of my title because my mentor told me like I couldn't really say like the idea what we're doing because it's very new. So he doesn't want anyone to know what we're basically doing. So I just presented like I just presented like the basic stuff, not like the very like. So okay, hello. My name is Luis Montano. I'm in the chemistry department. I'm doing research under the supervision of Dr. John Niersen, and I focus on developing new methodology for synthesis of benzofurans. So as you remember, this is the big picture, guys. Like, we start with a phenol ring, and we oxidize it. We basically remove the hydrogen from this ring, and then we create a benzofuran. So as you see, like, I didn't put like any of that stuff because he doesn't want anyone to know about that. So the main reason, like, what we are trying to make these benzofurans is because they constitute the core structure for more complex chemicals. Like, for example, like this chemical over here is used as an anti-HIV drug. So we can synthesize it from small molecules to this molecule. So I basically synthesize different, I synthesize some benzofurans by synthesize different substrates. So right now I'm just gonna talk about the substrate. So this is like a general reaction setup. Basically, it's kind of like cooking, guys. It's just like you work in the fume hood and you try to figure out what temperature you need to use, and you what it means by a nitrogen atmosphere, you basically have to put nitrogen gas, basically injected by a syringe or like different apparatus. But this is basically a reaction setup. This actually is you can see like here, like it has like a oil. We call this an oil bath. This might be at high temperatures, but most of my reactions have been room temperature or like very low temperatures, like minus 78 degrees Celsius. So these are the chemicals compound. Some of the chemicals that I synthesize this substrate here. I just added a bromine to the phenol ring, and I synthesize this one that I just added iodine. And what I noticed in this like very unique is like it's very cool, guys, when you do this stuff, because this one, it went from a dark brown color to an orange, and for the iodination, it went from a dark purple to a dark red. So after you finish doing the synthesis, so like creating these compounds, one of the hardest thing is to try to characterize it and purify it. So we have the different separation techniques. So every time you do a chemical reaction, you always obtain like different substituted compounds. So that's why we do the extraction first. This is what we call a sub funnel. Extraction funnel. Basically, we separate the compound according to solubility. Everything that is soluble in water will be mostly on the top layer, because we see like here two layers. And anything that is not soluble in water, like it has our compound, will be in the bottom layer. So, and after we do the extraction, when we separate soluble with insoluble, like we do rotary evaporation. We call it rotary evaporation because this is an apparatus that we use to remove the solvents, because we actually want to get like a powder, or we want to get like an oil. That's why we use rotary evaporation. So now it's like the purification techniques. This is the hardest part. So for purification techniques, we use column chromatography. Column chromatography, we basically separate the compounds according to polarity. So what we mean by polarity is basically you have a compound that is more electronegative than the other one. What it means by electronegativity is that you have more electrons than the other compound. And this is a column chromatography. This is what we use as a setup. We basically run solvents through the column, and then we separate the compounds according to polarity. In order to know how many compounds we have, we use a technique that is called thin layer chromatography, or TLC. And then according to the solvent system that you put in, you can see the different compounds separated. So you know how many compounds you had to separate when you use your column chromatography. And this one is used to monitor the reaction. So sometimes we don't know how many hours the reaction will take, or how many minutes. So we use this one to see when the reaction is done, basically. Another purification technique that I've been using is like when you have chemicals with very high boiling points, you do vacuum distillation. basically, like what we do with vacuum distillation, we put a vacuum into that compound. This is the general setup. This is like a vacuum, and then we boil the compound according to we lower the boiling point of the compound, and then we use a vacuum in order to extract the compound from other impurities that might be in the reaction. And when we characterize the compounds, we use nuclear magnetic resonance. Nuclear magnetic resonance, we do carbon NMR and proton NMR. The way we characterize these compounds basically is every single chemical will give you a different signal when you look at the data, basically. And that's how we know if we have that chemical or not. And then we do the mass spectrometry in order to see if we have the right mass that we desire for our compound. And that's it. I don't know. Any questions? Yes.